Happy Saturday. Saturday, Saturday, Saturday. Gravedigger. It's the wrong day. The wrong day to be invoking Gravedigger, but here we are. How's everyone doing? It's very inappropriate music. Like, give me your saddest, most melancholy piano music. The album cover makes it look like it's out of like a Studio Ghibli film. Sounds like it is too. Now I'm curious. All right. Okay, well, I couldn't figure it out. But I was curious, so that's the important thing, is just be curious, right? If everyone's good, everyone's having a good Saturday. We're still working on
I guess we all have future pants.
A pretty crazy refactor. That's fucking Future Pants song.
And the day after that.
All right, so the thing we set up yesterday was after we compartmentalize the space, we're supposed to get this compartment hierarchy. In this compartment hierarchy, it's supposed to let us know which compartments are in front of which compartments, like which compartments potentially obscure other compartments. And we're doing this in a way that we can support strange shapes, like horseshoe shapes even. Like we can support weird or like right angles. Like we can support strange compartments and still figure out which compartments are in front of which other ones, even if it's just partially obscured. The problem though is we're getting through this whole process and we return this hierarchy, and this hierarchy is empty.
And the day after that.
And so I'm doing something wrong. It's probably something to do with the bitwise operations I'm doing to combine together the compartment lists. So we gotta dig into this and figure out where the error is. Hey, Repo. How's it going? Happy Saturday. So on the agenda, we're still working out our like hierarchy of compartments. So like figuring out which compartments are in front of other compartments visually. And you know, now that I think about it, we actually don't really want to do it in the fill system, do we? Okay. Unless we do it for each direction, and then we cache it. But yeah, we're figuring all this stuff out. We basically set a bit field for each compartment that lists out which other compartments are in front of it, and then we return that array to the next step of the process so that we can store it in an entity and use it in other systems. The thing is, when we get it back right now, it is empty. So all the values are 0. I'm just going to put a debugger thing in here for now. Nice, you're doing something similar, working in contexts. Let's get it. Get some stuff off the task list. Hell yeah. Let's do it. All right, I'm going to just make a series of compartments here. So 0, 0, 0. Oh, 12, 0, 0. Interesting. 12, 0, 0. So 12 would be 8 and 4. So you're 1, you're 2, you're 4. So why are we working it out that way? Oh, wait, you're 1, you're 2. Yeah, well, that's a little weird. Okay, so why is it working like that? So we give them the count. This bit set parts I compartments dot add I. Oh. Yeah, I is the index, so that's fine. Compartments dot add I. So this is the index in to the compartment. Okay. And so we get down here, we say if these values are default, then whatever continue. Otherwise, we go for each compartment in compartments. If both of these blocks dot has this compartment continue. Otherwise, the index is... I don't love this, but this should work. So the compartment could already be 0, huh? So it's 0 based, isn't it? So we already have the index. For each compartment in compartments dot add. Oh, I'm doing it. I don't know why I thought compartment was the actual value. It's not the value. It's not the actual. It's not the actual value of that compartment. So it's not 1, 2, 4, 8, 16. It's the index of that compartment in the bit field. Okay. So I'm doing this wrong. So I don't actually need to get the index. We already have the index, I think. Yeah. Okay, I'm an idiot. I think that's causing some serious problems. So let's take that out. And also, why am I turning this into a uint? Because I didn't realize it was a u long. Also, that you can't just turn this into a u long uint. So wait, I do need the value. I think. I do need the value, right? Unless I make a helper function that lets me set a bit. So that's what I'm trying to do here, is I'm trying to make sure we add all the parts, but not this compartment part. So I need to be able to get the value from this. It's the easiest way to do that. Go to my utility function and let's think about this. So we have an isBit set. It should probably be called is the bit set on. We could just say is bit on or is bit off. So we'll call this is bit on. Could have another is bit off. Should actually come before. I know I could just negate the result of is bit on. And then what else we could do? We could do public static ulong set bit. Repo, you're almost exclusively web and app these days. From the few games you made back in the day, polymorphism inheritance would be the big thing. Is that still the general paradigm, or has it evolved? I think in practical standpoint, everyone is still very object oriented. I think the hot thing, the last, I don't know. The thing that is always being the hot thing that people get into and then get out of again is like entity component systems and like it's data-oriented design. People get obsessed with data-oriented design. I like data-oriented design, which is why I have an entity component system. I acknowledge it's not like the end-all be-all of everything. But people are getting more conscious about the implication of the actual hardware they're building for. When possible. There's always a wave. Yeah, it's always there. I mean, right now the thing people like, clean code is very much out of fashion now, right? Clean code, object-oriented stuff. That's not the cool thing anymore. And in fact, a lot of people advocate that, you know, clean code is actually more harmful than anything else, but more than it is good. I might make a little bit helper class for like bit manipulation, just for me. Because right now I have it in the utility class, but I actually kind of think I want... Maybe I just put it inside the utility class. Not cool until you bring on other developers that have to figure it out, or you come back for maintenance and can't read it. That being said, no time for that during MVP either, so it's a give and take. Yeah, I think it definitely, it's not... I'm talking about purely in games. And yeah, it's one of those things where it's like the bigger your team and the larger the scope and everything. There's reasons why clean code and OOP and stuff, you know, became dominant. And even in like Godot, that's definitely like the default. Using static di.utility. Using static di.utility. So we're going to say... But yeah, for a solo dev especially, or even a small team, where you might have one programmer, like one dedicated programmer. If bit.is on. All right, so this should get us, so if we pass in a bit field, and we pass in the index of the bit that we want to get, we just say field and when UL. I want set and a bool. Yeah, whatever. I kind of want variants like bit.set on, set off. But whatever. I think this is fine. I try to take the like very middle road approach where like there are good techniques for all of these methods, but as soon as you start thinking of them as like paradigms rather than just like conventions, I think that's where you get in trouble. When you start to think of a truth as a capital T truth, that's always what gets you in trouble. All right, so we're gonna say set. No, we're gonna say bit dot set. I guess bit set means like get the set back, and I guess it is get the set back, but it like I can say with and without. I can say with and without. Instead of bit.set, and then you have to set like a bool of whether it's on or not. Kind of like that better. Let me just look at this. So this is bit set. So I set the field, I punch in the field, I punch in the index, and I say whether we're setting it off or true. Off or on, but I pass in by true or false. I think I want to switch bit to bit.is. I don't think I want is on and is off. Yeah, you get into the vicious infinite loop, which we all fall into. Oh yeah. We're all in a strange loop. Okay, so set is kind of like, I think when people say a bit is set, they mean that it's on. If a bit is not set. So I'm gonna just have is set. Oh, I don't like is set. I don't know. I get so bogged down in names. Yeah, I really don't like, I really don't like the lowercase s, capital S, but I think is set is probably the best thing. Bit is set. So set is actually turn the bit on. And then clear is public static ulong clear. So we have clear, get, is set, and set. And in fact, clear can actually just be get field index not equal to 0. All right, so we say is set. So we want bit.clear. Yeah, I would love to get the crazy bitwise operations out of the regular code. That's a clean code concept I can agree with, right? Let's get the crazy implementation details outside of the function. I want a version of clear that doesn't take the index. It just takes a field. And that just returns 0. Repo, there's a lot you can do that's little that helps. Any variables you usually store on the top, find that way. There's not a ton of little things you have to change as opposed to just one place. Yeah, implementation details should always be stored in one place. I agree with that. That's why magic numbers are so scary. You're like, I multiply this thing by this number and I don't know what this number means. Like, I know that it's important, but like, what if that number changes somewhere else? There's lots of little things. All right, so this may work now. Let's see. right, so the goal, so we're just trying to see if the compartments in front, so we're having this long, oh, I should have done this lower. Oh, it hasn't crashed yet, so good for us. So we're gonna make a room here. Okay. And then we're gonna make another room here. Okay. We're gonna make another room here. Okay, nothing is working, but there are also no errors, so concerning. Oh, the compartment thing isn't even running. What the heck? Why? What did I do? Do I use some of these? What do I do up here that could be messing that up? I think I can think of something I'm doing that might be wrong, but not here. Is there anywhere else I'm using this system? I don't think so. Count 1, compartment 0. Okay, now it's randomly working because I added a debug. Count 2, compartment 0. Okay, that's wrong. And then what if I do the third one here? Okay, now it works. So why doesn't it work when there's only 2 compartments? So it's saying the first compartment is not saying the first compartment's not obscured by anything. Oh, I guess I don't know what order the compartments are being recorded in, do I? Well, it's saying one compartment's not obscured by anything. One compartment is obscured by... one compartment is being obscured by the second compartment. Compartment 2. And then one compartment is obscured by compartment 2. No, then this one says that this compartment is obscured by compartment 3 and compartment 4. There aren't 4 compartments. Maybe I actually want to take this line here that we're not using. Maybe I want to do this. Just so I can be like compartment index. Behaving weirdly, this. Compartment index -1. Oh, I see. Maybe I want to be able to like enumerate values. So yeah, that's not going to give me anything useful. So I want to be able to actually come out with a list. So actually what I want to do oh, can I not cross lines with this? There we go. I want to print out all the big boy body. Big boy body. Yo, you finally caught a stream. How's progress been? Hey, how's it going? It's okay. Right now we're working on our system. So we detect sealed compartments like rooms. And we're making a system right now that can tell which room is in front of which other room, like visually, so that you can tell which, if you're trying to look into a room, we want to be able to hide all the rooms in front of it, or at least hide the walls or whatever. So we're working on a system like that so that we can see into the ship. So that's kind of what we're working on. But yeah, progress is okay. How are you doing? Happy Saturday. Appreciate that you've been watching the VODs. All right, so I kind of want to know, I want to be able to list the compartment. What's like the easiest way to do that? Would it be to just pass in a string? If I would just wanted a list of things. I could just pass in an array of characters or something like that, maybe. Like if I do a bit dot like toString. No, you can't recursively call toString. Sometimes the autocomplete is just so dumb.
But it's not a thing about making it accurate. It's a thing about making it feel right. If it's an accident, there's an error that feels good, then you leave it in. You know, you want those.
Probably not the best way to do this,
About
but
making it accurate.
I could probably use a string builder. I probably should use a string builder than just making an array of characters. But whatever. Who cares? So we can say... So we'll say compartment. So I actually want an index. No, I don't care. So we're going to say compartment dot to.
But it's not a thing
We're going to
about
say
making it
bit
accurate.
to string. All right, what does that
It's
get
not about
us?
getting all the errors out. It's about getting it to feel right.
Okay, so here we go. We're starting to get data. So when we get 3 compartments, one compartment is just doesn't have anything in front of it. That's correct. One compartment has... So why don't we ever use the first bit for anything?
You know, take
I don't know why we're shifted over by 1.
That feels good.
We're ignoring the 0th bit here. But otherwise, this looks right. So one compartment is blocked by another one. This actually isn't how this should look. These ones should be like... It should go 0, 1, and then 1, 1 is what it should look like. I think. Although, no, maybe this is correct. So so we're blocked by this one room. We're blocked by these 2 rooms. No, that's not quite right. Because this compartment should read as blocking both of these. Do we actually keep going? Or do we only check? Oh, no. This should actually be even more different. So this compartment should only list this compartment. This compartment should only list this compartment. So it should actually be like 0 and then like 0, 1 and then like 0, 0, 1. It shouldn't look like this at all. So yeah, we're setting these values wrong. I don't think there's a problem with our helper functions we just made. But I am trying to check that. Oh, for one thing, we're never setting anything, which is a little weird, a little concerning. So we make our hierarchy, which is a list of the number of compartments that we have. What we could do is we could say if count is equal to 1. We could say less than or equal to 1. We could just say return hierarchy. And we don't need to do any of this. Because if there's just one compartment, that compartment doesn't have anything obscuring it, and we can just save ourselves some time. Otherwise, we got to go through this. So for each coordinate in the block, so when we're determining like a cutaway, a compartment-based cutaway, we're going to do it recursively. So we're going to be like, okay, this is the compartment we want to look at. What compartment is blocking this compartment's view? Or what compartments are blocking our view into this compartment? Okay. What compartments are blocking our view into those compartments, etc., etc. It's a recursive thing. So, it should be pretty easy here. So for each set of coordinates, we need to build a list of the compartments that this coordinate belongs to. I don't actually know if we need to do this phase. But maybe we do. So we're recording a list of indexes. So we basically go through the list of parts. So parts means partitions or compartments here. So we grab our block. We get its list of compartments. So like what compartments does this block belong to? It could be up to 4. It could be between 0 and 4. If it's 0, we just forget about it. Otherwise, we need to get the indexes of all of those bits. Maybe I make this a function, like list compartments. Although I don't really want to make a new list every time I do it. So maybe I don't. I could say bit.list and you provide the list. Whenever I get stuck, I start writing helper functions. I don't know, I have a problem. I'm not going to make a helper function for that. Big boy, you're a fairly new Godot programmer. Could you ask how I stay motivated for long projects like this? Yes, you can, because that is a good question. The trick in my mind, having done this and tried to make bigger projects before, not just in Godot, but like previously I was a Unity hobbyist developer for like 15 years or whatever, till I picked up Godot a couple of years ago, almost 2 years ago now, a little more than a year and a half. The trick in my mind is to never let the project become unplayable, right? So like we're in the middle of working on stuff, right? But I can still just hit the play button and do stuff. And I say never. Obviously you can't do it never. Like sometimes you need to do a big refactor. But you need to keep those moments as short as possible. Like whenever if you do something where you're like, oh, I need to do a refactor, the game is going to be unplayable for like a week. If the game is unplayable, like if you've broken it in a fundamental way for more than like a day, I think you're in trouble from a motivation standpoint. Because the longer you're working on something and you like can't get feedback on it, it's really not good. Okay, we're starting to get some interesting results here the more compartments I add. It's not correct because there should only ever be one bit set for any of these. And it should actually look like 0, 1, 1, 1. It should be like second bit 0, third bit 0, fourth bit 0. It doesn't actually matter the order. The fact that I'm still not using the 0th bit for anything is a problem. There's some error there. You never thought about that? Yeah, I think it's crucial. I think motivation really depends on feedback. And if you put yourself in a loop where you're not getting any feedback on what you're working on, I think it's really hard to maintain that motivation. What kind of stuff are you working on, though? I'm always excited to hear about people's projects. We have a Discord. It's small, but there's a lot of Godot developers on there. There should be a link on the channel page. If you want to hop in there, unless you already are in there, feel free to ask questions. Like, we're always happy to help troubleshoot people with the Godot bugs and stuff. Or if you just want to share your work, I'm trying to build our community up so that we can all help each other. No pressure, though. Just offering it as an option. I try not to bully people into engaging the channel. All right, so so we go through all of these. So when we're setting our components, let me see, because part of this could actually be in the interior flood fill when we're doing this. There actually might be a problem here when we're setting the compartments in the interior flood fill. So the U-long compartment, so this is the actual compartment. This is the actual compartment value. I think I might change this to like part value versus like part index. Because I use the word compartment interchangeably to either mean the value of the compartment itself or the index of that compartment. It's like, is it a U-long? Then it's the value of it. Is it an int? Then it's probably the index. All right, so when we do so we should actually start from the top here. So we set partition count to 0. So we set partition count to 0, and then we increment it. Every time we do an interior flood fill, we increment the partition count. And then we pass in that count as a value. We say math.pow 2. So we raise 2 to the count's power. So that should give us... Oh, so are we skipping a value? Yeah, because 2 to the first is just 2, isn't it? Yeah, 2 to the power of 1 is 2. That's a problem. And then 2 to the power of 0 is 1. Oh, no. Okay, so So we actually need to wait to increment the partition count until after we do this, huh? Because we want to start at 1. So we're starting at the wrong point. So I want to say 2 to the power of 0, which gives us 1. Oh, I see you. I see you sliding into the server. Welcome in. It's good to have you here. Yeah, we have a troubleshooting channel. We have a share your work channel. We have a resources channel. I probably should be doing a better job at curating that. Yeah, welcome to the community. I'd love to follow along with whatever you're working on, or even just your journey to learn the engine. Because I engage with this engine kind of obliquely sometimes, because we're doing so much stuff outside the engine just in C#. We really haven't dug into a lot of the engine stuff on this project. We do game jams and stuff that we make entirely in the engine with like GDScript and everything, but all right. So if we correct this, what we should do is we should say if partition count, we should say if partition count is greater than or equal to 64, throw a new timeout exception. Number of internal partitions may not exceed 64. And then here we're going to pass in partition count plus plus. That way we get to send in the 0, so we can raise 2 to the power of 0, and then we can increment the partition count. That should help us with the not recording the 0th bit thing. That might solve some of our problems. Let's check that at least. Great to be here. You're for sure. Link any cool stuff, or if you're super stuck on something. Yeah. That is what we're here for. It's supposed to be kind of just a chill co-working stream, and we're trying to just be a chill, co-dev community here. We're all working on something. Many of us more than one something. Okay, so now when I do this... Oh ho! I might have fixed it. Let's see what the third one looks like. Not quite. I haven't quite fixed it. So... this isn't quite right. It's shockingly similar, or it's interesting how it's working. Oh, I love this song. I'm gonna like this one. Oh, I already did. So it looks like the first compartment is blocked by the second and third. The second compartment is blocked by the first, and the first compartment is blocked by the second. That seems circular to me. Like, that feels circular, which makes me uncomfortable. So let's look at what's happening there. Because that implies that the first compartment is in front of the second and the third. Or no, that implies that the second and third compartments are in front of the first. Sure. That's technically true. And then it's saying that the first compartment is in front of the second. That's not possible. And that the third compartment is in front of the second. So the third compartment's blocked by the second. The second compartment is blocked by the first. If that was true, the first compartment should be blocked by nothing, right? But instead it's saying it's being blocked by the second and third. Yeah, that's circular. That's deeply circular, and we need to figure out why that's happening. Oh, I almost just leaned back into my green screen. Thought there was like a lock mechanism where I can engage to prevent that from happening. All right, there we go. There is a locking mechanism. All right, so I think we're assigning compartments correctly now. Let me double check to make sure that's happening. So I'm just going to make sure that the interior flood fill is doing this right. So we can additively include this compartment. And in fact, I want to say parts equals bit.set compartment. Oh, that in fact doesn't work. Oh. We could have set that takes two U-longs. So in the compartment hierarchy, this is probably where the error is now. So we're making a list. So if bit.isSet so if the bit is set at this index, then we add that index to the compartment. I'm going to say this for each index in compartments. Just to be super clear. All right, so we go through all of our indexes. We look to see if are both of the indexes set, in which case this isn't the edge of anything. Then we continue. Otherwise, if this index isn't set in the positive X block, then we want to add to this compartment's hierarchy we want to say bit.clear, so we want to get this index out of the positive X blocks, and then all the remaining ones we want to add together. In fact, we could even phrase this differently. We could phrase this as bit.set hierarchy index. This is a superficial change, but I like it. Because again, if I get stuck, I start just making superficial changes until I can think. I find that if I just move things around enough, it eventually clicks with me, and I'm like, oh, this is why it's behaving this way. Gotta go. Good luck. See you again soon. Yeah, no worries. Thank you for stopping by. Have a great rest of your weekend. See you later, big boy. All right, let's look at this again. I don't think I did anything that would change the behavior of it, but I'm just, like I said, we're just trying some stuff. Oop. The next thing we got to do is fix this error with the when we're at z index 0. When we're at z index 0, bad things occur with the flood fill, and it's like a known bug, but I just haven't felt like dealing with it yet. Okay, so far so good. We might have actually fixed it somehow. I'm not sure what we did, but maybe the helper functions truly did help. Nope. So, okay, so it works with 2 now, where it says one compartment's in front of the other. And now it does this crazy thing again, where it says the first compartment is obscured by the second 2. Which is, like, technically true. But I don't believe the system is capable of making that distinction. Like, it's sort of true, but I don't want that to be the logic. Yeah, there's circular reasoning happening here, and I don't totally understand how. Let's try a different test scenario. So let's have one compartment in the back here. Oh, we shouldn't have done this at the top of the index again. So we're gonna make one compartment here in the back. And then we're gonna make one compartment out here in front. Like this. Now I have, oh, I only have one. Well, now we're gonna have 2. And now we're gonna make a third compartment. Okay, now there's 3. Okay, so it says, this says 1, so 2 of these compartments should be 0 because there's nothing in front of either of them. What I think is happening is if you look at the corner case, we look at this room and we see that this corner piece belongs to all 3. And so if you grab this and then you look one further down here, you say, oh, this is a different compartment. And because it's a different compartment, you say, okay. Oh, we should be removing... when we do this, we should be removing not just the index of the compartment that we're considering. We should remove the index of all of the compartments in the core block. I think that's what we should be doing. Let me see if that's correct. So my theory is we say minus parts. Okay, clear doesn't take a value, but it should. Or clear doesn't take 2 values, but it should. So clear public static ulon clear. Big boy. Oh, before you go, should you catch the streams on Twitch instead or the future? Or are you going here? No, you're going wherever you want. I'm sorry, you're probably already gone, but wherever you want. We're streaming in 4K on YouTube. So the visual quality, the bit rate and everything is much better on YouTube, but there is a chat delay beyond just my own, you know, lack of focus and awareness. Whereas Twitch is only in 1080p. So it's like if that doesn't matter and you're more into like you'd want a quicker back and forth between me with the chat, Twitch is maybe the better option. I actually just signed up for the 2K beta on Twitch. They're apparently asking for, or they're apparently letting people pilot 1440p Twitch streams. I signed up for that. We'll see if I get that. So I think over time, especially, I think Twitch is switching over to AV1 encoding and stuff like that. Over time, I think Twitch will probably be the better experience, but there also currently aren't any ads on YouTube because I'm not big enough. I say that and someone's like watching this from the future and they're like, what do you mean there are tons of ads? At the moment, I'm too small a streamer on YouTube to get ads, so is my understanding. Maybe they still run ads and I just don't get money for it. I don't know how that works, but it's all about you and what's best for you in terms of, you know, the platform you choose for your streaming. I'm just happy to have people hanging around, you know. So if we want to just remove a value from a field, we would say we do this. We do negate field or value, and then we negate that whole thing again. Negate's the wrong word. We flip the field or the value and then flip the sum of that. And that should allow us to clear values instead of just indices. But yeah, I think we figured it out, which is rather than removing just the index of that particular compartment, we need to remove all of them In which case, I maybe don't even need to do a for each. We could probably do an is any. If we're gonna do it this way. Let's confirm that this behavior works correctly, and then we can maybe get rid of the list of compartments. That'd be cool if we could. Nope, I went too far. Broke a hole in the wall. Oh, this doesn't seem to be working. Nope, I definitely broke something. Maybe it's because we're doing it for each index. Let me see. Let me see about this. So let's hide this. And let's rewrite a version of this where we don't go through the whole list of compartments, where we just do a single check. So what does that look like? So if I'm right about this corner case thing, then what we want to do let me make sure my utility function isn't just wrong. No, that's right. So instead of going through all the compartments, we just check everything once, right? So we say so first we check to see if the blocks are default. Then we can check if the blocks are, if bit.is set. So we check to see if the blocks are default values, meaning we don't have anything there. We don't care. Otherwise, if the blocks are so if those blocks are the same as parts. So if we share all the same compartments. Oh, I don't have a version of that function. Can I do that? Can I say public static bool is set ulong field ulong value? So we just say get field value is not equal to that. Okay, so I need a get function. Although that doesn't totally make sense in this context. Oh, we don't need to do a get. We just say value. We say if field and value is not equal to 0. I should maybe call this like has. Rather than is set. Happy Saturday. You are correct indeed, Fusionist. Hey, Carol. I do not. I'm sorry to say I do not know Russian. But hello, welcome in. I barely know English. Oh, I need to say parts. Why you do me like that? C#. Haha, Fusionist knows some Russian. There you go. All right, so if we're going to not go through every index in the compartments list, but instead we're just going to try to operate on the total value of the parts thing, that is interesting. So what we're doing then, so if that's not true, we go through the next thing. We say if not bit dot is set positive x block dot parts. We can't say index, so we say parts. Oh, we don't want to check. We don't want to compare it with 0. We want to compare it with value. I'm going to call this has all. And then I'm going to call this I'm going to make another one called has any. How are you doing, Fusionist? So bit dot has all. So if this field has all of these values, then we continue because we're not dealing with anything differently. Or wait, do we want to check that the other way around? I guess it doesn't matter what order we check that in. Maybe I do want to check it the other way around. So we're checking to see, is our field... No, we want to... We're checking to see if this field, the field of these two blocks, has all of the values in the block we're comparing to from in the core block. I'm calling it the core block. It's the block that we're like extending from for the check. You're chilling? You're gonna try sending that album demo to labels? Hell yeah. That's awesome. All right, so if it doesn't have it all, then what we're gonna do is we're gonna say if not bit dot. You want has all or has any? So we're going to say if not bit dot has all. So if there are any compartments and parts. Oh, no, this is the opposite, right? We do the opposite check now. We want to see if there are any values in positive X block that aren't included in the parts. Wait, why would I flip that here? We were doing a process where we were checking each individual bit in the bit field, but I'm trying to see if I can do it all at once, because doing it one by one breaks down when we're at the corners. As always, it's a corner case. The corners are weird because a corner, if you have a cross-shaped wall section, the corner piece knows all 4 of the compartments on each side of it. So if you go index by index, you get way different behavior than if you just check the overall value of the bit field. So I'm trying to see if we can do this check by whole cloth, but I'm struggling slightly. Just because it's Saturday and my coffee is wearing off from breakfast. That's cool. We're chilling. Little progress. Little bit by bit. Get it? Bit by bit. All right, I'm done. Thanks. Thanks, Fusionist. All I really want from streaming is a platform to tell dad jokes, you know? Just puns and things. All right. So we're trying to imitate this. The if not bit is set. If this particular index isn't set in the parts, in the neighbor's parts. So if one of our parts isn't set in their parts. So we are doing a has all check. I'm just not sure if I need to flip this. Because if the positive X block dot parts has all of our parts, but it has additional parts. Yeah, I think we need to flip this check. I think it's like this. Like, do you have additional partitions? Or do you belong to more compartments than the point we're comparing from? If you do, we want to add those. So if you don't, then we say hierarchy index equals. Oh, we don't have the index. Oh, we need the index. That's why. I see why we had the index now. Okay. Okie doke. That's why we did it like that. Because otherwise I would need to use like a... Need to do something else. We could then just go through each value in that. But we should be able to do this way. All right. Okay. I understand. I understand why we did that. So when we do it with the index here, we get this weird thing. We just start putting rooms in here. So we have a room here. And then I'm going to put another room in this corner here. Okay, so this is obscured by one room. Okay. Okay, this is... One of these rooms isn't obscured by anything. And that's the problem. I think we need to like not use corner pieces. How do we not include corner pieces in this? Like side corner pieces. How do we guarantee to not include those in this check? So we don't actually want to check from the corner piece. We want to check from... I guess we could check the negative. We could try to disregard that. Oh, I got someone to spam. Or I got some spam bot here on Twitch. I get to ban them. It's like my favorite moment of the day. Get out of here. Blasted. Get blasted. All right, so yeah, I think the problem for us, the core problem, is that when we do this hierarchical check, we are checking from the corner, from the side corners, so like the left and the right corners. And I think that is causing us to misidentify the hierarchy here. Like, how does this room think it has anything in front of it? It shouldn't. Maybe something else is happening that's strange. Let's try to remove the corners. So the easiest way to remove the corner would be to ask... It would be to ask, let's look at the negative blocks as well. And so if you check your negative blocks and neither of them belong to your partition, then you don't want to check from there. I think that's right. So if I wanted to disregard the corners, I would say, are one of the negative blocks not part of our compartment, or they don't have the index we're checking? I could also add an unofficial constraint that says that you can't have 2x2 walls. I want to be able to support 2x2 walls, like double thick walls. I want that to be like a conscious choice of like, this is like a heavily armored section of the ship. Maybe you just don't allow double thick walls. I could see that getting really messy really quickly though. Yeah, I think we need to try this corner thing. I think this is where the problem is coming from. I actually don't totally understand the circularity of some of this. So the first compartment is being blocked by compartments 2 and 3. The second compartment is being blocked by compartments 1 and 3. The third compartment is being blocked by compartments 1 and 2. And the fourth compartment is being blocked by all of them, yet is not blocking anyone else. So that would make me think this is the fourth compartment, because it thinks it's being blocked by all the other ones, which honestly doesn't make any sense how it would get that thought into its head. So this is, I think this is compartment 4. I should add a debugger that like just shows me the compartment that I'm in. It shows me all the compartments. It would be easier for me to debug it if I knew that information. So where would I do that? In the tile system, probably. Where are we invoking cursor coords? Only here? I think I could do it right here. Debug.writeLine block buffer .get coords .parts. But it not just parts, it would be bit.toString. I would say utility.bit, I guess. I'm going to import using static. Oh, we got an ad break coming up. I'm gonna go get some water when we hit that. All right, this should help. Let's add a cutout. Let's say if save this. It's not equal to 0. All right, I'm gonna grab some water real quick. Be right back. All right, I'm back. Thanks for hanging out. All right, so we got a little debugger hookup now. I actually do want a thing like I can flip where I can show in the UI all the attributes of a block. I want to add that at some point. Probably sooner than later. Babinski. Bob. As I might call you. Okay, so this is compartment 1. This is compartment 2. No, these can't both be... Okay, no, this is now compartment 2. That's the other thing, is the compartment list is, like, not stable. If you could either have the power to spawn unlimited money or the power to instantly finish any game idea, which would you choose? Oh, man. It depends. That's a fun thing. I could single-handedly destroy the entire economy with that first power. Which could be fun. Here's the thing about the instantly finish any game idea. I don't have that many game ideas. I'm working on one project now, and I have like one more project that I'm interested in after this. Beyond like jams, obviously I come up with little ideas for jams. But like in terms of big game ideas, I have like 2. It's like the number of game ideas I have. Oh, this is interesting. This is wrong. What's happening here? 333 001 010 100 110 333. The walls are being given the wrong coordinates. The corner is right, but these walls are like very wrong. Yeah, the corners are right. Maybe the corners aren't the problem. Well, I'm glad I did that. I'm glad I checked this. Huh. Any game idea can technically make you a lot of money. Yeah, but you said unlimited money. And so if someone gives you the opportunity to have unlimited money, you got to think about how you can totally destroy the system with that. Like maybe we could bring down the entirety of capitalism with that superpower. Like if you were able to spawn unlimited US dollars, you could probably create a new economic paradigm like overnight. Obviously, they would probably cause like a world war or something and it would probably not be good, but it would be something. See, I don't know, it's a tough choice. All right, so we found the thing that is behaving wrongly, and it's in the floodfill. So so this is compartment 3, this is compartment 2, and this is compartment 1. So this wall, these walls here, let me undo that so I can just select it. So these walls here, these are showing that they belong to both compartment 1 and compartment 2. So compartment 1, compartment 2. The wall is correctly saying, hey, I belong to both of those compartments. Because you can see it's 1, 0, 0, 1, 1, 1. So that's correct. So this is 0, 1, because it's the second compartment. And this is 0, 0, 1, so it's the third compartment. But when you look at a wall between 0, 0, 1 and 0, 1, what you get is 1, 1, 1. Which means this wall thinks it belongs to all 3 compartments, which is wrong and definitely the source of our bug. So now we got to dive into the interior floodfill and see why that's happening and why it's happening specifically there. I think once we figure that out, we'll be a long way. Bob, without money, you would have no incentive to do anything in civilization with Paris. That's what capitalism wants you to think. Civilization survived for a long time without money. Our society is based around the concept of artificial scarcity. It used to be based around actual scarcity, but now it's based around the concept of artificial scarcity. Because if there was actually, you know, I'm not an economist, so I'm not going to get into that. But superabundance is like you know, a whole thing. This idea of superabundance. And it's also a lie. But okay. Thus ends my soapbox speech about late stage capitalism. But how's it going? How's it going, Babinski? How's your Friday or Saturday? How's your Saturday going? You're enlightened? Yeah. Go read like Society of the Spectacle or something and just then be sad. And then just be unhappy. All right. So we are applying. You know what I think is happening? I think because at one point, I think it's because the compartments aren't stable. So every time I make a new compartment, the old compartments aren't guaranteed to stay in their same place. What was compartments 1, 2 might become 3, 2, 1. Like the ordering of them might be changed. And I think that's happening. And so I think we're oring the compartment lists in the blocks, which we want to do to some extent. But I'm now wondering whether we need to do like a wipe whenever we run this. If we need to like start over. It would probably behoove us to just wipe the whole compartment assignments. Unless we can figure out a way to do it cleanly in the interior flood fill. I don't think we can, is the thing. We have something in here that helps, I think. It's this part. It's the if blocks. So if we're talking about a solid block, if we hit a solid block with the interior flood fill, and what we do is we OR the parts list with the compartment, which is correct because that allows us to describe that aspect of where the walls share. Oh Lord, where should we put something in here to do this? We could save ourselves some effort maybe by just, so we get a list of blocks. So when we do an interior flood fill, so when we compartmentalize and we do an interior flood fill, what we could do is after the exterior flood fill, if we just operate on the buffer, we should probably just reset the buffer. We should have like a reset compartments function. I'm trying to think of a way that we could do this without doing that, and I cannot think of one. And then so the exterior flood fill is actually an interesting function then. We actually don't need to set anything in the buffer. If that's the case. If we just reset everything to 0 anyway, why do we do a fill volume check here? We can't actually consider... buffer. We do a blind buffer.get. That's probably what's causing the error. Because we're doing this flood volume, this exterior flood volume. We actually can't do it like this. We can say... So we can't get the block, essentially. We could do a get or default. So we could say buffer get or default. In which case we could just get rid of this whole section. In which case we could pass in a buffer 3D read only. Not that it matters. And then we can just do this simple check out here. Okay, well, I think we incidentally fixed the Z indexing problem. But what we need to do now is we need to add a reset compartments function. So we would say buffer 3D read write block buffer, say blocks. Are spans enumerable? Just like normally? No. So I would just do a loop. And just say for variable I equals 0, I is less than blocks dot length, I plus plus. And then here we would just say blocks dot set. We would say I. We would say blocks I, blocks dot get I with parts equals 0. So super simple. Super simple. In fact, I don't like having loops on the same line like that. Badar2384, how's it going? Welcome in. Happy Saturday. All right, so what we're going to do is just to make sure that we do this right, we're going to reset it every time. We're going to reset all the compartments of all the blocks. We're just going to sneak this into the compartmentalize function. Would it be easier if I pass in the bounds? I mean, it would be faster if I pass in the bounds. So instead, I could just say AABB bounds. So we would say, instead of going by I, we would instead go for each vector 3i coords in bounds, set coords, get coords. Is this developing something? Yeah, we're working on an FTL-like. So we're working on a game like FTL Faster Than Light. We're working on an isometric 3D version. So we're kind of taking FTL, which was top-down 2D, and we're kind of making an isometric 3D, more side-on kind of version of it. But it's still about simulating, you know, the management of like a spaceship. Very Star Trek style. All right, so to save ourselves some trouble, so bounds is going to be game.world.usedBounds. We are going to say reset compartments, buffer, bounds. And then if bounds.volume is 1, we'll return because that's all we need to do. This should fix that particular problem. This could be private. In which case, the exterior flood fill doesn't actually write anything anymore. So we can actually get a buffer 3D read only. Not that it matters much because reset compartments is read write. But whatever. Principle of least permission or whatever, right? All right, so this should have fixed that weird issue with the walls. And that might have fixed... Actually, let's try to do this at z-index 0 and see if we actually fix that error. I don't believe that we fixed that error. But maybe we did. Oh, no, we did. Okay, cool. Alright, so we're going to make a little space. We're going to fill that space with a few rooms. So there's one room, room 1. Here's like room 2. So room 0, room 1. And then so... Room 2 says that it's blocked by room 1. That is correct. And then let's add a room 3. Go down here. So room 1. This is room 1. This is room 2. This is room 3. So this says, so it's front to back. So room 1, which is at the front, isn't blocked by anything. That's correct. Room 2 is blocked by room 1. And room 3 is blocked by room 2. That is all to the good. And then let's just double check the walls here. So your room 3, these walls, let me unselect. These walls belong to room 2 and room 3. This is room 2. 2 and 3. So this is room 2, this is room 1. Your walls belong to room 2 and room 1. Okay, so that part is sorted. Let's do one more quick check by just making another room over here to the side. Let's make it weird. I still kind of want to do something about the corners. I think corners don't work quite right. So there should be 2 rooms that aren't blocked by anything right now, but that's not what's happening. Room 1 is blocked by room 3. Room 2 isn't blocked by anything. Room 3 is blocked by rooms 1 and room 2. And room 4 is blocked by rooms 1 and rooms 3. That doesn't seem right. So you're room 1. You're room 4. So room 4. You're room what? You're room 3. And you're room 2. Okay, so room 2 not being blocked by anything seems correct. This one is room what again? This is room 1. Oh, because your corner, so this corner piece here. Three. So you're room 1. You think you're blocked by room 3. Yeah, okay. And then room 4 is this one. Yeah, you think you're blocked by 1 and 3. Okay, I understand why room 1 thinks it's blocked by room 3. It's because of this corner piece. Okay, so what if I do the thing I was trying before that didn't work because of, I think, this specific issue? Badar, one of this is interesting to you, but it takes time. Not totally sure I follow. All right, so we're going to try to clear the parts, all the parts associated with our original block here. We're going to see, this should fix the corner problem. I think it didn't work before. You know, I'm going to add another little hook to our little debugger to temporarily make this easier. We're going to say private I basically just don't want to spam the logger when I do this anymore. Parts. So we'll say a ulong private ulong parts. Instead of saying if block.get.coords.parts is not equal to 0, we're just going to say it's not equal to parts. And then we're going to say parts equals this. This should hopefully keep us from spamming the debugger when we're doing this. All right, so let's check this out here. So we make this room. So this is compartment 1. This is compartment 0. This is compartment 1. Okay, and this is going to be compartment. So this is going to be compartment 1. This is compartment 2. This is compartment 3. Okay, the parts thing didn't work. It's a shame. I think we don't want to consider corners because corners don't actually obscure anything. Like if there's a block here or there's a room here at my corner, at the corner of this room, that doesn't actually block anything. The parts thing doesn't work because did I just write it wrong? So if not bit is set index, and we say hierarchy index equals bit.set hierarchy index with bit.clear. Do I flip this? Do I have this the wrong way? Should it be parts and then positive? No, that should have worked the way I had that written. Let's switch back to index then. And then let's figure out how to discount corners. So the easiest thing to do would be to check a negative block. So we could also say block negative, X block, blocks. So what we want to do is if we identify... So if these are default, then it doesn't matter anyway. What we want to do then is say, so if they're not... So if at least one of these blocks, so if we're on at least... So if we're in a corner... So if we're at... If the positive Y block... Positive Y block... We're at the edge. What we want to do is we want to check to see if the negative X block... We want to make sure that the negative X block it doesn't have to be the same, but it needs to have this. It needs to have our parts. It needs to at least have the same parts. Yeah, we want to stop at a corner. We want to stop at our corner. You're back again? Welcome back. How's it going? So how can I identify our corner? Can actually move this definition down here because we don't care about it in this case. All right, I need to look at a couple cases here and I need to think about this. So what if we had something like this? So I'm going to make 2 rooms. Or I'm going to make 2 sections. So here's one section. There's another section. And then I'm kind of just going to make rooms that are kind of like offset from each other. This. Yeah, like this. So we want to check from like a corner like this. This isn't what I would consider a corner. I really need to add back a little outline that can follow around your cursor. A little easier to see what you're exactly clicking on. Right now, it'll only do that if I click. So if we're looking at this coordinate, we're 110001. We're looking here, we're 100001. We're here, we're back to where it's 01001. So I want to check all of these. I guess what we can do is we can compare one of the negative coordinates with one of the other. So we just need to identify whether we're on the left or the right corner. Because I don't want to check from this point. Because that's not obscuring, actually. Like, if you're a block over here... Like, this is a bad example because I perfectly offset all of these rooms. But I did that on purpose because I wanted to make sure that the selection or the process we have works when you're talking about poorly formed... Not poorly formed, but overlapping rooms. I want a selection that doesn't disregard, like, this corner. Like, we don't want to disregard this corner. Because it's not our corner, it's the corner of this other room. But if we're checking this room, we want to disregard this corner and this corner. This is the corner that matters, so I'm just going to keep thinking about this corner. So this is our compartment bit, the 6th bit. So this has a 6th bit, this has a 6th bit, this has a 6th bit, this doesn't. And this doesn't. So this would have a 6th bit. So we kind of need to know the bit of the compartment that we're working on. Maybe we need to do this. I really don't want to check every block for every compartment. Would this be the only bit that we all share? Oh, it's really hard to tell whose corner we are, huh? Yeah, it is. All right, so how do we identify the corner of this? So we're looking at this room. We're going block by block randomly. We look at this corner piece. So we're going through all of the indexes of this piece. And we're identifying stuff. So this piece belongs to compartment 2, compartment 6, and compartment 7. And so it's going to tell compartment 6 and 7, it's going to say, hey, compartment 2 is in front of both of you. I don't want it to do that for compartment 6 because it's on the corner of compartment 6. So how do we tell that? So we look at this index. So we know we've got, let's just look at index 6. So if we look at all of our coordinates here, this one doesn't have 6. This one does have 6. So if a positive block has this compartment, this is really dumb. There's probably a more elegant way I can make this check. So these 3 blocks all have the 6th bit set. These 2 blocks do not. So if one of these, so if it's our bit and a negative and a positive also have that bit, that means we're at a corner. I mean, it could also mean we're in the middle of the room, but we're already checking for that. So we look at our bit, we say, in this example, we say, okay, does the positive y have that bit? Great. Does the negative x also have that bit? Okay, then we're at the corner, and we don't want to do anything. Okay, that's easy enough. And that doesn't work the other direction because neither of these have that bit. So we're not gonna mix this up. You have the bit, you have the bit. So it actually needs to be if positive x has the bit and negative x doesn't, and negative y has the bit and positive x doesn't. So there's a very particular arrangement, and that is a corner piece. Okay. I just have to check all 4 neighbors. That's easy. That is easy to do, actually. Hey, Skywalk, how's it going? How's your weekend? All right, so we already do this check, and then what we're going to do here is we're going to do this check. We're going to say if positive x block we're going to say if bit dot, oh, we need to do this in the particular index. We actually have to do this per index. Okay. So first we say if is bit set parts and index. So this is another corner check. So this is our corner check. So we get through the corner check. Or not the corner check. We get through the are you the middle of a room check. So if you're in the middle of a room, we don't care about anything. We just skip. So now we're not. We're at an edge somewhere. And what we're needing to do is we need to check to see if we're a corner for this particular bit. And the way we do that is a really stupid thing where we say if bit.isSet should I just do the two checks? Should I just do like if is set positive x block index positive x block dot parts? Should I just take a block and break it down into? No, I shouldn't do that. You made a Jeremiah Johnson nodding skin? That's great. That meme is so widespread. Even though I don't think anyone watches that movie anymore. All right, so we're checking a precise thing, which is the positive x block and the negative y block both set, and are the corresponding negative x block and positive y block not set. So it's just this 4-piece, and I'm just gonna do them as two checks because I can't be bothered. So we're just going to say this. We actually don't need to do it like this, do we? We could say positive x block dot parts and negative x block or negative y block dot parts. All right, so we can check the other one now. Doing all of this just to try to... So are we one corner? If we're at one corner, then forget about it. For this particular index. We're at the other corner for this particular index. Also forget about it. Okay, that should eliminate corners from being considered. Let's see if we achieved that. So now we're gonna do another more careful, like we're gonna... Here, I'm gonna make it like this. Do like this. So your room 1, or your room 2 and your room 1. Room 2 is blocked by room 1. Cool. Okay, so if we get this, if I did this corner thing right, this should be good. There should be 2 rooms that aren't blocked by anything and 1 room that's blocked by both. Yeah, all right. Okay, we're disregarding corners now. All right, I think we did it. Room 5 is blocked by room 2 and 4. Your room 2, your room 4. Yeah, that's correct. So what if I make another room out here? Let's see. This is going to be a good test. So I'm going to lengthen this a bit here. And then I'm going to make a room here. Is this a good test, actually? Room 2, what's room 2 blocked by? Just room 1. Your room 4, room 1. Yeah, sick, we did it. Okay, so the block hierarchy is correct now. We've got, the cutaway is not right, but that's because we need to recode the cutaway to actually work with this hierarchy. We actually have a hierarchy of which compartments are in front of another compartment. What we need to do is we actually need to expand this process to also consider verticality. Because the system also needs to work up. It needs to work like, it needs to look up and say like, what compartments are above me? And in fact, that needs to happen before this. We actually need to consider that for, so this continue. So if we're in the middle of something, then we need to look up. So we could do that first. We could say, we could do all that. We should look up, this is going to be annoying. All right, I need to think about that. But yeah, we need to add verticality to this check, to this series of the way of setting up this hierarchy. Okay, cool. I'm pleased with the progress today, though. We figured out that bug, and we got horizontal compartment hierarchy. The horizontal compartment hierarchy sorted out. We just need to figure out verticality. We'll probably save that for next stream, because we've already been live for a few hours, and it is Saturday. What's going on elsewhere here? All right, cool. I don't think the Z stuff is going to be that hard to figure out, because we only need to look up. And by up, I mean down. We need to look negative Z, which is up for us, towards the camera. And that should be easy. Should we just try to do that now? I'm torn. Let's make a simple pass at that, just because I would like to finish this hierarchy thing and then be able to move on to implementing the actual cutaway using the hierarchy. I would rather not have to keep working on the hierarchy next stream. So let's see. If we needed to check above us, we want to check above us from blocks. We want to check above us from blocks in the room. So we still want to do our... We don't want to check from just the edges, because right now we're just checking from positive edges. We want to check from anywhere inside. And in fact, we don't even need to check from the edges. We would want to check from actual interior. Can we do it as an initial pass here? Can we say something like if bit.is... Could we say I kind of want a has only. Which I guess has only is just this. If block or if parts what I'm asking is if parts I guess I do want to has only. Because that's what I want to ask. I want to ask is only this bit field set? Public static bool has only ulong field integer index. Is field exactly equal to 1 UL index? Are these values exactly the same? And then I could also have a public static bool has only ulong field. Is field not equal to value? So we'd say if parts, we'd say if bit dot has only field index, not field, parts index. So are we only this, are we like part of the interior of this compartment? And that's where we'll do the check from. So if it is, then we'll do this. So we're just gonna put the Z check first, and that way we don't disturb our whole process for the horizontal stuff. And in fact, I actually don't think I can do this check right here. Can't do this continue, can I? Oh no, I can, because are you at the edge? If you're at the actual edge of something. This is such a stupid early out. I don't know if I like it. So we'll say block negative Z block. Blocks.get or default. I don't know if it's vector3i.back. It's actually vector3i.forward. So if we're in the interior of this compartment, okay, if we're in the interior of this compartment, then we're going to check above us. So what we're going to do is we're going to say if bit.has only parts index and negative z block dot is empty. Well, what does is empty check? Does it check to see if it's just a default value, or does it do something else? No, it literally just checks the form. That's not right. That's not what we want. So we want and negative z block is not equal to default. If it is equal to default, then there's no reason to check. All right, so if it is, what are we doing? We're just checking for... Do we need to do any additional checking? Like, because what if we're going up and up is also part of our compartment? Do we care? Not really, right? We could still do this hierarchy index equals bit dot set hierarchy index bit dot clear. So if we clear this, so we're saying negative z block dot parts index. So we're just removing this index from this will do nothing if the compartment above us, like if we're in a big cargo hold and let's say like we're in a cargo hold that's multiple z levels up, even if we're just looking at the block above us and it's just also part of this compartment's interior, it won't negatively affect this assignment. It won't do anything, but it won't negatively affect anything either, so I don't think we need to do an additional check. And then we can go through down here and we can do the horizontal stuff. I think that's reasonable. So let's run that and let's see if that works. So we're going to start by just trying like 2 compartments on top of each other. Let's just try that. That should be the easiest thing to try. So 2 compartments. So compartment, this is compartment 1. This is compartment 2. We're saying compartment 1 is obscured by compartment 2. That is correct. And then if we add some more compartments here. All right, your compartment, whatever. So your compartment 5, you're not blocked by anything. Cool. Your compartment 1, and you were blocked by compartment 5. Your compartment. Okay, I think this is all good. I think we've got the compartment stuff right. So here's why this has to be recursive though. So like this compartment 4. Compartment 4 knows that it's in front. It's blocked by 2, 3, and 8. And you're what again? Compartment 4. Let's go check. Let's look at double check that that's true. Compartment 4. Okay, compartment 4. Compartment 4 says that it's blocked by 1, 2, 3, and 8. So there's 2, there's 3, there's 1, and there's 8. Cool, but it's also sort of blocked by... It's also technically blocked by 5, but that's okay. Because 8 knows that it's blocked by 5. If we go up here. Yep, 8 knows that it's blocked by 5, and it should know that it's also blocked by 6 and 7. It does. Hence why this is recursive. So compartment 1 is blocked by compartment 8. Compartment 8 is blocked by all of these. So when we go to cut away everything blocking compartment, whatever compartment this was, I said, it will cut away the compartments that directly block it, and then it will cut away the compartments that block those compartments. And that's how the cutaway by compartment system is going to work. And there will probably be considerations for the cursor coordinates. So there will probably be cursor coordinate considerations as well. But those should be really easy. We do need to get the corner pieces to stop being cut away. But that's fine. That's going to be easy. Okay, well, I'm pleased. Our compartment hierarchy is getting built out correctly. It's a little unfortunate that each block needs to look at 5 other blocks to do it, but it works. And it's not that bad. I mean, the Z one is going to be... Checking the Z is a bit rough. But also inevitable. So if we know this, can we just do this and then continue? Do we not need to do any of this other stuff then? Because if this is true, we absolutely know we're in the interior of a compartment. So I can actually do this and then continue, I think. Save us the trouble of checking the rest of this stuff. Because if you're looking up, you don't also need to look out along the sides for a given compartment. And in fact, you can continue the whole... we could continue out here. So actually what I want is not a continue, I want a break. And in fact, I don't actually need to use the index then. I could actually put this outside. I think. I would need to pick the index. I would need to be like, is compartments dot length 1? I would need to know the index though. I could say if compartments dot length. It really doesn't matter. It really doesn't matter. It might be like a little more efficient to like not go into this loop, but whatever. If we break out of it at the very beginning, who cares? Although I guess if we do this, yeah, no, let's do it outside. Because there's no reason to do this check for every index in compartments. We just say if compartments dot length is 1 count. Ooh, we could actually do it like this. We could actually move this part down here. I wonder if we could do a thing. Could there be a bit or like count bits or something like that? Bit dot like count. Count set. Set count. Let's just say public static integer count long field. So it'd be like for variable I equals 0, I is less than 64, I plus plus. Variable count equals 0. We could say if field is equal to 0 UL, just return 0. Otherwise, we want to go through and we want to say if field and I could do a has any. That wouldn't give us a count. So this is fine. This seems fine. Count plus plus. Turn count. So we could actually, before we bother with doing this compartment set thing, we could say if parts, we could say if bit dot count parts is equal to 1, then we do this whole thing, or then we get the negative z block. I do need to know the index of it though, but we can do that. That's fine. So I can get you up here. Now what we can do, we can add another function here called like index. Say get value. Say public static int get index. That's not really right. I'm gonna not have a utility function for that because that's a little weird what I'm trying to do here. Oh, I don't need to get the index because if the bit.count is 1. Oh, no. I'm not getting that count. I'm saying, so we say this, and we put this up here. There's only one part in this parts. Then we want to do the up z look. By up, I mean we want to check above us. Because if we only have one part, that means we're inside a compartment. We're like not one of the exterior walls, but like we're in an interior space in the compartment. And that's when we want to look up. So we just figure out which I is set. I could just have I could have a utility function that's called like first. We'd have like a public static integer first long field. And what it does is it just goes through and it finds the first set bit. We could say if negative z block is not equal to default. We could actually say variable first equals bit dot first parts. We could say a first. Well, we want to know if the bit count is 1. We want to make sure that the negative z block is that. So we can say bit dot has only index, parts index. Yeah, we don't, this is all nonsense. Then we just pass through this. And in fact, we don't actually, oh, we need first. We can say index equals bit dot first. Parts. And then we can say continue. That saves us a bunch of work. Okay, that way, if we need to check above us, we don't do anything else. We just check above us and we move on to the next coordinate. We don't mess with anything else. That's nice. I guess I should check to make sure that still works. We're going pretty late today, but it's kind of because I've been doing a bad job during the week and making sure that I'm streaming enough. I'm trying to make up for it a little bit. So we'll do that. Do that. So I'm going to make a few different compartments here. Oops. All right, so compartment 1 is obscured by 2 and 3. Compartment 2 is not obscured by anything. And compartment 3 is obscured by compartment 2. That should be good. So this is compartment 1. Is it? Is this 1? This is 1. You're obscured by 3. Hold on a second. Hold on a second. Oh, shoot. This has only 1, so this is not... Actually, I think that's fine. We're protecting ourselves against this weird edge case that I just realized that we have. So let's make a wall. So let's make a wall that's like 2 Z levels tall. So here's a wall that's 2 Z levels tall. Let's make a compartment down here. Why? Oh. That's weird. Why do you look like that? Why are you like this? All right. And so we're going to do this. So this is like very unlikely to ever occur, but This is something we want to protect against possibility. Oh, I can't do it like this because I'm an idiot. Let's go down a level then and do it. If it looks like I'm doing something weird, it's because I am. So if we have a room in here, let's just forget about this. I can't erase this right now because of the way I've made this. We're just going to pretend it doesn't exist. So if I have a room here, I have a compartment here and I have a compartment down here. Well, this actually isn't going to work now, is it? Oh, maybe it will. This is actually an interesting question. So I need to seal this up. There's an edge case here that I'm super curious about. So this is compartment 2. This is compartment 1. Compartment 1 says that it's obscured by compartment 2. That's incorrect. And it's because it's at the edge of something. What about the other possibility? So we're going to do this. We're going to draw this line again. We're going to make a wall. So we're going to make this wall. And then we're going to have a room down here. And a room up here. So technically this room, room 1, is obscured by room 2. But the problem is that it reports the same thing even if we're talking about something like this. So even if we're talking about like the opposite, which is this. So we have 3 rooms in this kind of weird arrangement. So we have room, this is room 3, this is room 2, and this is going to be room 1. So it says room 1 is obscured by rooms 2 and 3. That's not really right because this is room 3 and it really doesn't obscure room 2, but it's because we're looking up from the edge here. So we actually need to do a bunch of stuff. So we actually need to do more than just check the bit thing. And in fact, we could probably get away with not checking the bits at all then. I'm going to get rid of this edge case because I don't think it does anything for us. So we need to actually check this way. So we need to say if... Basically, if all of these are default except, we can say if negative z block is not equal to default. So if we have a block above us, we want to consider some stuff. And now we need to ask if we need to ask. Negative X block. How do I want to do this? I could do this by parts. I could look at the parts. I could say I could do all of this. I guess no, I don't actually want to do that. I don't want to and all that. I'm just going to say if negative X block is not equal to default. Hey, Anonymous, how's it going? Actually, we're checking to see if they are equal to default. Actually, we don't need them to be default. We need if any of these are outside. So parts or no, we don't want or. So we want to say if parts this is 0. Let's do it. Let's have an empty function. You finally reached your first itch game. You're so happy with that after just over a week developing. Hell yeah. Congrats. That's awesome. So we have clear as like an instruction. Can we have clear as a bool? Is that bad form? Public, static, bool, clear, belong, field. Yeah, that is bad form. You could just ask empty. Say is empty. Or is clear. Actually, we'll just have an is set that only takes a field. Actually, we just ask is field not equal to OUL? So if any of these are the case, so we can do or. So if any of these are not the case, not negative Z block though. So if any of these are the case, we are just going to continue. Whoop. Need another parentheses. Stop doing that. Stop reformatting my code. So if any of these, so if we're not at the edge, or if we're not definitely in the middle, then we want to continue. So this I might still move down. How are you? I'm good. I'm good. We're doing a long stream today. It's Saturday. We're working on developing this hierarchy of our compartments, detecting like what compartments are in front of the others, and we're like almost done. There's like an edge case that we identified, like a literal edge case. It's all about actual corner cases and edge cases for us. I see where it got the term. So this we don't need anymore, really. So we're checking this. We're asking if any of these, or if we're at the edge of any of anything. If we're at the edge of anything that we don't want to do this check above us deal. I guess that's not true. We want to check to see if we're at the back edge. If we're at the front edge, we do want to check above us because that does block us. Okay. So we make this a little simpler. We do this. We could actually do it like this. You've just used structural navigation. I don't want to do it. Yeah, we're just going to do this. So if either of our negative blocks are outside, we don't want to do this. But we do want to do a check if it's forward. Okay, that's fine. That's fine. So because of that, I realize now that there's this weird case. Maybe I'm trying to get too fancy. So I'm thinking about this case like we have where there's this room, and then there's this room offset above and in front of us, so that we're like kind of diagonally connected to this room with like a shared wall. There's actually some annoying problems with this. The system could actually fail under a bunch of circumstances. I'm thinking maybe we just don't care about that right now. Someone would also need to be real shithead when they're making the levels for this to come into play. So maybe I'm trying to be too clever. Maybe we say this, and so if we want to do this up thing, so we want to check above us, and we also want to check we only really need to do this edge case check thing if we're... So we can still do this bit count thing. We can get rid of this. We can just have it be like this. So we still want to do this bit count. We just move it down here. Because if there's a compartment in front of us. We actually don't need to do this. We're just trying to deal with an edge case here. So we're just going to continue to do that. I'm going to put the bit count thing out here as well, because that also... all of these conditions need to be true or we don't want to do this. Let's just try to reduce the nesting. Kind of don't like is set. I kind of want to do has. And we could do a has that is empty. I guess has all is the same as has, isn't it? We can just make this has. I wonder if I want to last. Public static int last elong field. I'm sure I won't ever be bitten by any kind of Indianness issues with that. He said confidently. So if negative Z block is not equal to default and the negative X blocks don't have any values, have no values associated to them, like none of their bits are set, is that what I want? I want them to have values, don't I? The opposite of that. I want to make sure that we're not on the back edges of anything. Yeah. And if parts count as 1, so we're in the interior. I guess this check is a little duplicative, but it's not totally. It describes different things. All right, I think this works. If this is good, I'm gonna call it here. We're gonna see. So we're gonna set up our weird little test case, which is like one. I'm gonna make a 2 tall wall here. So there's our little wall. And what we're gonna do is we're gonna make a room back here. A room up here. So these rooms like barely touch. But this room in the front does obscure the room behind it. So room 1 is obscured by room 2. Correct. Okay, that's correct. Here's another edge case which we can't capture, which is like, what if there's a room in front of it, but it's like way off over here? Honestly, we might end up doing a different approach. I just don't want every block to have to check every other block. I don't want a block to have to scan forward in each direction. Yeah, I don't want each block to have to take check an enormous volume in front of it just to figure this out. I'm hoping that this is going to be mostly fine if we do it this way. All right, let's do one last sanity check. Let's put a room back here. So this room should not be registered as in front of anything. And it is not. Oh no, it is. Shoot, how is that possible? So you're room 3, you're room 2, room 1 considers room 3 to be in front of it. Dang. I thought I accounted for that. Let me check your blocks here. So you're 1. Oh, you need to be, it needs to be, you need to have a value other than. No. So you're 0. You're 1. It has. Oh, so either of you, it needs to be. Yeah, no. It needs to be both of you, not either. You both need to have a positive value or some kind of value. That was an or versus an and problem. All right, one more quick check to make sure that was done correctly. And then we're done for the day. So we're gonna make a little room. And then above this room, we're gonna make 2 more rooms. That are like oblique. We're at like basically a diagonal, but they share one wall. So here's our main room.
It's not exactly clear whether they even truly exist. Or could
I don't like whoever this artist is. It bothers me. Oh, it's abstraction. I guess I like some of their stuff. I just don't like all this voice sampling.
That's great.
I don't like that. If I'm playing instrumental music, don't give me voice samples, please. Person responsible for this stuff. All right, 2 rooms, 3 rooms. All right, room 3, no one cares about. Room 2. Room 2 is in front of room 1. Okay, cool, we did it. There's still an edge case where if I do this, if I put a room here, put a room like this, so that it's not overlapping technically at all with that room down there. This room is not going to be correctly identified. Actually, maybe it will. But I bet I could come up with a way. This way it will because it's sharing walls with this. I bet I could come up with a condition where it doesn't work correctly. Because, yeah, this room is going to say that this room is in front of it. Will this room say that? So you're room 3. No. Yeah, so if we go down here, this room is... I guess if we just do aggressive z-index culling, it's, like, not going to matter a lot. And it's unlikely that we have a room down here that doesn't have any rooms in front of it that eventually touch this room up here. Like, there are worlds. I think there's a construction where we fail this test. But I think it's so unlikely. You'd have to have a room that's basically off by itself. And that's not going to really work. Unless I add a lot of scaffolding or something. I don't know. That's such an edge case. That's not even an edge case. That is a detached case. Greetings from Finland. Hey. Sumi? Maybe? How's it going? Greetings. I don't even know what kind of time it is over there then. It's 3 o'clock. Is it like early morning over there? Or is it just late at night? I guess it's just late at night, huh? I don't know. I guess that becomes the same. Late at night becomes early morning, doesn't it? Yeah, okay. Cool. Well, welcome. We're wrapping up. We've just spent the last 4 hours developing a system, or perfecting. I say perfecting. Getting a system that works for modeling how different compartments in a ship visually obstruct the other compartments. And we have a model which works now. And so that's what we did. Hope you're having a good Saturday. I think we're gonna wrap it up here and F off so I can go do some other things. But yeah, this was a nice long stream. I wanted to go a little long because I've kind of been failing to have sufficiently long streams during the work week. So I wanted to go a little longer today. And it's just fun. A bunch of people showed up, said hi, familiar faces, new faces. Yeah. I'm off ramping here, but I hope you all have a great rest of your day. Sorry you came in right at the end. And yeah, enjoy your weekend, and I'll see you all next time. We'll be back Tuesday. We stream Tuesday through Saturday, right here, right now. Bye.
Maximum warp.
Maximum warp.